welcome to all of you who have took time to join this session. I'm really honored, and it's my privilege to talk about our Cisco Industrial Ethernet switches in this session. And other sessions will cover our other aspects of industrial networking, which is we talk about routers, we talk about wireless access points, we'll talk about security. But this particular session we are focusing on our industrial switches. My name is Vivek Bhargava, and I'm a product marketing manager in our industrial switching product team at Cisco. So I'll jump right into it since we only have like 30 minutes. When we talk about networking at Cisco, we basically group them into three buckets, so to say. One is the enterprise networks, as you see on the left. Now, these are networks that you deploy, very well. You deploy them in offices, you deploy them in your branch offices, you deploy them in campus, you deploy them in data centers, etc. So these are all climate controlled spaces. They are dust free. You put them in racks. They work great. And on the extreme right are industrial networks. Now, these are the networks that exist in industrial settings. So, for example, in manufacturing floors, in utility substations, or in cabinets along roadways, and in oil and gas fields, in mining operations. So these are totally different networks, but they obviously require the same kind of resiliency, even more, I would say. They require the same kind of robustness as you see in the enterprise networks. And then in the middle is the middle ground, where you have enterprise network that needs to extend beyond the office walls. They need to extend into, say, parking lots. They need to extend into outdoor spaces. And the requirements of the networking equipment for all of these is quite different. For example, in the enterprise network, as I mentioned, these are all exist in climate controlled spaces where the other ones don't. But our approach to all of these networking buckets is that we start with a common network architecture. We have networking equipment that our core is similar. They run the common operating system. They're managed by the same network management system. And what it results is that it's uniform across. Even the networking equipment might change, but the architectures, the management, the security that they provide are completely the same, which means that now you can use your skills in these different network scenarios more effectively and more efficiently. So let's jump into our industrial switches. Now, these obviously work in the industrial space as well as the rugged enterprise networking space. And when we talk about our industrial Ethernet portfolio, we talk about three different buckets, so to speak. One is at the top row, you can see the DIN rail portfolio. So these are compact switches, and we call them Cisco IE 3100 for IE for industrial Ethernet, 3100, 32, 33, 34, and the latest one is the 3500 switch. As you can see, they are quite different from switches that go into racks. These are compact switches which typically do mount on rails, which are typically inside cabinets in industrial spaces. Then we have the IP67 portfolio in the middle. And as the name indicates, these are IP67 rated, which means that they are resistant to dust, they're resistant to vibration, they are resistant to moisture, to liquid spills, to wash down, which is a very critical requirement if you are mounting these in outdoor locations, or you're mounting it in industrial conveyor belts or other places where you require that high degree of resiliency, and even more than what the DIN rail portfolio can provide. Then at the bottom, we have your typical switches, the rack mount portfolio, which consists of the IE 9300, and these come in different form factors as well, different capabilities as well. Some of our models are all copper, some all fiber, and some are mixed ports, which give you the copper and fiber ports for added flexibility. Now, all of these are industrial, which means they're ruggedized. They can withstand extreme temperatures. They can withstand the dust. They can operate very robustly and very reliably in industrial operating conditions. So let's see, how we are applying our industrial Ethernet technology to what is happening in the industries. So over the past centuries, I would say, there have been several revolutions that have happened in the industrial space. So starting first with, say, usage of steam, usage of basic mechanization, to mass production in assembly lines, to let's say usage of robotics and so forth. And now we are in the age of cyber physical systems, where AI and software are revolutionizing industries. And it's not just manufacturing or utilities, but it's all across manufacturing, utilities, transportation, mining, oil and gas, renewable power generation. They all are now modernizing their operation. They're looking to moving from basic automation to autonomous operations, where software is the driving factor. They're moving from these hard appliances that do only a single thing to now more software driven, which can be, which you can modify, which you can adapt, which you can innovate upon more easily. And then again, they're moving from traditional analytics. They may be gathering data, but they're doing some analytics. Now they're putting AI algorithms to work. They're deriving these insights for better outcomes, more data-driven decision making, etc. And the core thing is that the network is now even more front and center for all this to happen. It's not just a connectivity source. It requires much more than we were used to. So some of the use cases, if you see, people are using machine vision. These are cameras mounted on assembly lines and processes to monitor what is happening in production. If the process is working okay, if the product that is being made being made correctly, is there any defect in there? So these cameras act as eyes and ears to see what is happening and to be able to analyze what is happening. Then we look at some of the more recent trends, such as virtualization. People are looking at removing some of those hardware appliances which were fixtures in industrial spaces, now moving them to software. And what does this give them? It's the same thing. It gives them the ability to consolidate their infrastructure within servers. It gives them the ability to move all those PCs and PLCs out from the factory floor and into a data center. And then we're looking at a lot more use of cloud applications. AI algorithms operate on large scale of data, which is uploaded to which is transferred to cloud, where they can do their analytics. And so what we find is that the network is becoming even more necessary and even has to fulfill more stringent requirements for all this to happen. For machine vision, it needs to provide that high level of power over Ethernet to power those cameras. It requires more bandwidth to carry all of that video that is being generated from cameras into an AI server. For virtualization, it requires, again, high bandwidth fabric, which is large enough to support all of those thin clients that are coming in place of PCs into VDI servers. For PLCs, the programmable logic controllers, which actually control motion of a machine, it requires a very stringent, very low latency, very low jitter network in order for them to function properly. So now when you move them from hardware-based to a software-based, now there's a network in between. So the network now has to fulfill those latency and timing requirements that are necessary for this to function properly. And in the edge to cloud case, now that we are moving some of those applications over to the cloud, we have multiple layers of network. There's a local area network. There might be a service provider network through an internet. There will be a data center network. So now we have to navigate through all of these different networking layers. So you require that sort of observability. You require that performance assurance that your application will still work and the network is not going to be a bottleneck in its functioning. So when we started looking at building our own industrial Ethernet, we were looking at all of these requirements, all of the things that our customers were doing, and we're trying to build a network that will help our customers do the things that they want to do. So when we look at all of these, moving to software, moving to the cloud, all those kind of things, it increases the attack surface. So one of the basic requirements that our customers want now is to have even more stringent, more robust cybersecurity built into the network. We require the high bandwidth. We talked about the low latency and jitter requirements. The Cisco's answer for that is to build your AI-ready infrastructure. We talked about, again, the scale. We talked about the adaptability that we want the network. We want the simplicity. Obviously, we don't want to sacrifice simplicity. And that we can do by bringing IT skills to OT networks. And you will see how we have constructed a network that can very easily bring those IT skills that your IT department has already developed and perfected into the OT to be able to manage this. So let's see. Let's talk about one thing at a time. So I'm going to talk a little bit about the security and how we are bringing security and fusing it into the network. If you look at how traditional security has worked in industries, you will see that the solutions have been very much fragmented. So you have one product doing one thing, second product doing the other thing, third thing, fourth thing, and it just becomes unmanageable. It becomes too complex because now you have to worry about bringing all of these things together. You need to make sure that they all kind of work together, deploy together, they are scaling together. So it just becomes a nightmare once you start scaling it. And also it kind of leads to a shadow IT problem where, because of it's so complex, because of it's so hard, people are tempted to put their own little things in there, which is then becomes even more difficult to control and manage and secure. So what's our answer to this? What we do is we fuse security into the network itself. So think about a switch that is connecting all of these robots that you see on the conveyor belt. There will be motors, there will be all kinds of things. A switch is there, anyway. So what our answer is, why don't you put all of these things into the switch itself? Let the switch be your eyes and ears. Let it have that visibility into what is connected to the switch. I mean, it's there at the right place. So we built an application that runs within the switch called CyberVision, and the CyberVision is an application that looks at all of the traffic that is coming to the switch, and is able to do the deep packet inspection to see and to determine what are those connected assets, what are their vulnerabilities, and then be able to provide that ability for you to formulate policies for segmentation. Again, that's the segmentation that the switch can do on its own. It doesn't require a separate firewall, access control application or anything. That's all kind of built into the switch. And finally, the switch is also a remote access gateway. Frequently you require your vendors, your staff, your contractors to be able to log into these robots and different machines that you have. And instead of deploying, yet another hardware, yet another server, why don't you just put it in the switch so that now the switch acts as that remote access gateway. So now let's talk a little bit about our use cases and how our users, our customers want their how they're building these use cases and how we are responding to their needs. So I described 4 use cases in the beginning. So let's talk about those. First is we talk a little bit about machine vision. And if you look at the diagram on the left, you will see that there are the cameras. So machine vision is not new, right? So it has existed for some time. People have been putting cameras. But the key difference is that earlier, these are very much rules-based, which means that you program the rules, whatever you are scanning, whatever you're looking for, there's kind of already being programmed into into the algorithms which are running on these industrial PCs right next to those cameras. So this is very static. Now, if you go to the right, what we are seeing now is that people are using these cameras and then taking all of that video streams out to an AI server. So either they're doing some kind of edge processing on the cameras itself, or they're putting all of these things and sending these video streams to a backend server. So now what you can do is you can apply these AI algorithms to learn as you go along. You can, instead of static rules, now you have AI algorithms that can process this data and come up with, with more accurate determination of what could be wrong. And obviously, the network has a role to play here, because now we are moving from those static systems to a high bandwidth network that is required for collecting all the data and to power those cameras in the first place. So how are we doing this? So I'm going to talk about this new IE3500 rugged series switch. This is one of the new switches that we launched at Cisco Live this year, back in June. And this is our flagship switch. It has all of the things that you need for these vision systems to work. It can provide up to 24 ports of PoE for connecting all the cameras. It has, it can go all the way up to 90 watts per port, actually. It has, 10 gig of SFP ports, 3 of them, to be able to connect those high bandwidth streams over to the AI system. But also the key things that Cisco does in all of our PoE equipment is making sure to minimize any interruptions in PoE to those cameras. So we have things like fast PoE, we have perpetual PoE that ensure that that uptime is maximized as much as possible. Similarly, we have this heavy duty series for vision systems, and these heavy duty, like I mentioned earlier, are IP67. So you can see the difference. Instead of RJ45 jacks, they have these M12 jacks where you actually screw it on so that it's protected from water and etc. But we have some new innovations in our heavy duty switches. For example, this one has up to 60 watts of PoE for your vision system. It has 2 10 gigabit ports for that high bandwidth connectivity to AI system. Again, it has that fast and perpetual PoE for reliable PoE that you need for those cameras. Next, let's talk about virtualization. So again, virtualization of PCs is not new, but for industrial PCs, you require that even a higher degree of reliability. You require that higher level of performance than you might need on, say, an enterprise network. So for example, here now we are using, instead of PCs being on the floor, we're just using thin clients with local servers in the back end, providing the actual software. As you can see, this can greatly simplify your connectivity problems. Whenever you need a new PC, you just fire up a new session in the VDI server, and you have a new PC. If a PC goes down, you bring it up really quickly. So it just sort of reduces the cost. It reduces your maintenance needs. And by being able to consolidate all of that infrastructure into the servers at the back end. So what do we need here? Of course, we need that high bandwidth, which we already covered. You might need that PoE to drive those thin clients. But we also need this high fabric, this high capacity, scalable fabric to connect all of those thousands or tens of thousands of PCs which are out on the factory floor over into that VDI infrastructure. So what do? We have the 3500, which supports SD access and supports this layer 3 fabric architectures, including SD access, which is a key mark for Cisco, and also the BGP EVPN architectures. all easily managed by Catalyst Center, as well as it provides that this PTP over fabric support for best synchronization across multiple entities. Now let's look at yet another one of virtualization, which is the emergence of virtual PLC or programmable logic controller. Now this is an extreme form of virtualization because not only it requires those high bandwidth, it requires those fabrics, but it also very time dependent because as you can see, the virtual PLCs are controlling machines, and for controlling machines, you need very, very strict timing. And this timing has to function over all the other things that are going on in the same network. So the same network might be handling your vision systems, so it has those big data pipes going. The same network has to now handle these control messages, and you don't want your heavy duty video frames from interfering with these control traffic. So we see two different ways in which people are using, and this is relatively new, so you will hear a lot more about it in the coming days. But people are virtualizing their PLCs and putting them onto the servers in the data center, as you can see in the left figure, and it kind of extend over the whole factory. But for larger factories, you can also deploy these PLCs, virtual PLCs within a cell. And so these are, but the networking requirements don't change. And what you really need is some kind of an extreme QoS, so to say, which is known in industry as time-sensitive networking. So the way we do time-sensitive networking in the IE 3500 is we use frame preemption. And what it does is that once a switch sees that it has to, there's a very high priority control traffic with strict timing requirements that needs to be transmitted, it actually suspends any kind of traffic that might be going on at that point of time, any kind of lower priority traffic that might be happening. So what it does is that it allows these control frames to actually go even before the previous frame has ended. So it takes precedence over the previous frame. And in that way, you can almost guarantee that, or you can at least reduce latency and jitter, and make sure that your PLCs, even though they might be far away from the machines they're controlling, are still being very effective. Oops. Now, the fourth thing that we talked about was how you can best use your cloud applications. And one of the examples of the cloud applications that we see out there is how do you optimize traffic lights in a city? So you have all of these sensors, and you have these traffic lights, all over the city. And local control is not going to give you an optimum result. So what you need to do is to consolidate all of these traffic, move it over to an application in the cloud, which can have a global view, or at least a citywide view of your traffic requirements, and how where most cars are going. Is it different for morning to evening? Whether it is it's a holiday, whatever it is. But what you need from such an application is that you need to make sure that the network is up to supporting this, and you need to be able to monitor and observe that network. So what we do here is, in addition to the high bandwidth, in addition to the PoE that you need, in addition to the fabric, you require some way to measure and observe the traffic all the way from the device, where the sensors are, where the traffic lights are, all the way to the cloud application and back. So we use and this is the first time we're doing this in our switch, is putting this 1000 Eyes agent. So if you're familiar with 1000 Eyes a little bit, 1000 Eyes is a software application that can give you those insights all throughout your networking stack. Again, from your local area network to to the service provider network, to the data center. So if you get that end-to-end path visibility, you can more effectively and more confidently deploy those applications. Now, just to kind of round out, there are some other, we see, a very high growth for PoE devices, which require more power, such as, those PTZ, video surveillance, some cameras that require heater and blower in substations. We require these big LED, outdoor signage. They require a lot of power. So what we have also now come up with, we launched at Cisco Live, is new versions of the Catalyst IE 3100 switch. The key thing about these switches is that they're extremely small. They're much smaller than even those, the small things that, they're typically, they're actually made for space constrained areas. But now they're still as powerful as some of our larger switches. And they're able to provide that, 90 watt of PoE, even it's at a slightly smaller scale, but it's effective where it's needed. The biggest thing about this 3100 switch, I should also mention, which is not present in other switches, is something called as PoE boost. Now, this is a way that these switches can provide usable PoE power, even with input voltage as less as 9.6 volt DC, which means that you don't have to reconfigure your electricity, your power layout in order to use PoE. Similarly, we have, these days people are using more adaptive robotics, robots that have cameras, they have sensors. So instead of, strictly being rule-based, they are now, they're AI-driven, they're adaptive. And for this, you require an IP67 switch, which is small enough to mount within the robotic arm. And which provides all that robust connectivity that all the sensors and the cameras need. For that, we launched a new IE 3100 heavy duty switch basically for that kind of connectivity requirements. And finally, I talk a little bit about how we are bringing IT skills to OT. All of our industrial devices share the same operating system as our enterprise devices. They are managed by the same management system, the Catalyst Center, which means that now they function almost exactly the same as our enterprise devices, except now they're industrial strength. So now by marrying all of these, best of enterprise with the best of industrial, we are now able to allow our IT customers to be able to now use their IT skills and all the equipment and all the tools that they are familiar with into the OT infrastructure. And we're going a bit further. We are now introducing not only on-premises management with Catalyst Center. You will see that now we're going to be starting to do cloud-based management with Meraki. Again, the idea is to make it as simple for our customers as possible. If you're familiar with Catalyst Center, if you're familiar with Meraki, this should be fairly easy. Ultimately, I want to talk about how switches are no longer just switches. They are really an industrial AI platform. From segmentation to visibility to observability to application hosting and ultimately unified management with on-prem or cloud. This gives you a picture of all of our industrial networking portfolio with switches, with wireless, with routers, and with management and automation. And we'll be covering more of this in our upcoming sessions. So I leave you with some of these resources. We have a lot on Cisco.com. You can look at all of our industrial Ethernet. You can compare models. We have what we call as CVDs or Cisco validated designs, which will help you make the most of our products, put them together very easily. And finally, I want to mention not a promotion, but how we are offering industrial securities with our IE 3500 and 9300 switches. You can basically get the Cisco cyber vision, and the SEA applications at no extra cost when you get the 3500 with Network Advantage license. And ultimately, lastly, I would encourage you to schedule a free, no obligation consultation with one of our experts. We can go through demos, we can go through your scenarios, we can suggest an architecture, we can suggest the switches that you need at no obligation. So back to you, Emily.
Thank you so much, Vivek, for that valuable and informative presentation. Here are some of the upcoming sessions we're hosting in the coming weeks, and we hope to see you there. So with that, thank you so much for attending the first session in our Industrial Insider webinar series. The recording will be made available and we'll keep you informed of upcoming sessions. Thank you.
Yeah, thank you very much for your attention. I hope this was useful to you. And we'll see you again.